Hello everyone. Hope you all are doing well and studying properly at your home. Today in this session of online classes, we'll study the chapter 6, Heat and Energy of Physics. As you can see on the screen, your syllabus is marked. According to the reduced syllabus, topic coming in your course is concepts of heat and temperature, anomalous expansion of water, and greenhouse effect and global warming, and the scientific definitions of all the above topics. Let us start the session with this inspirational quote. Each body is made up of molecules, and these molecules are in a state of random motion, and each molecule exerts a force of attraction on other molecules. So internal energy, total internal energy equals to internal kinetic energy plus internal potential energy. Internal kinetic energy is due to molecular motion. Internal potential energy equals to due to molecular attraction forces between the molecules. And the heat energy of a body is the internal energy of its molecule. When a hot body is kept in contact with a cold body, the cold body warms up and the hot body cools down. That is, the energy flows from hot body to the cold body, and it is called the heat energy or simply the heat. So we can define heat as heat is the internal energy of molecules constituting the body. It flows from a hot body to a cold body. As a unit of heat, it is joule and abbreviated as capital J. CGS unit of heat is erg, and the relation between joule and erg is 1 joule equals to 10 to the power 7 erg. Other units used for heat are calorie and kilocalorie, and 1 kilocalorie equals to 1000 calories. Relation between calorie and joule is 1 calorie equals to 4.186 joule or 4.2 joule. We can understand the flow of heat energy from one body to another from these two examples. Touching of ice cube. When we touch a cube of ice, we feel cold because heat energy from our hand passes to the cube of ice. And touching of iron rod, in this case when we touch the hot iron rod, heat energy from the iron rod passes to our hand. Our next topic is temperature. We know that when a hot body is kept in contact with a cold body, after some time the hot body becomes less hot and the cold body becomes less cold. That means there is a flow of heat from hot body to the cold body. So the body which imparts heat is said to be at a higher temperature than the body which receives heat. Thus we can say that temperature determines the direction of flow of heat. When a body receives heat energy, the particles constituting the body start vibrating more vigorously because their internal energy has been increased. So we can define temperature is a quantity which tells the thermal state of a body. That means the degree of hotness or coldness of the body. It determines the direction of flow of heat when two bodies at different temperatures are placed in contact. If the two bodies are at same temperature, no transfer of heat will be there. The SI unit of temperature is Kelvin, written as capital K. Other units are Celsius degree C, Fahrenheit degree F. And the relationship between all these units are T Kelvin equals to 273 plus T degree centigrade, and the relation between degree Celsius and degree Fahrenheit is C upon 5 equals to F minus 32 upon 9. With these two relations, we can convert one unit into another. Sometimes heat and temperature are assumed as same thing, but they are not. The difference between heat and temperature are as following. Heat is a form of energy obtained due to random motion of molecules in a substance. Means it is the internal energy of that substance which is due to the motion of molecules and the attraction forces between the molecule. Whereas temperature is a quantity which tells the thermal state of a body. That means the degree of hotness or coldness of the body. And when the two bodies at different temperatures kept together, the direction of flow of heat will be from hot body to cold body. SI unit of heat is Joule, whereas SI unit of temperature is Kelvin. Dependence. The amount of heat contained in a body depends on mass, temperature, and material of a body. Whereas the temperature of a body depends on the average kinetic energy of its molecule due to their random motion, that is, internal kinetic energy. Heat is measured by the principle of calorimetry. Temperature is measured by a equipment called thermometer. You all are familiar with thermometer. Two bodies having same quantity of heat may differ in their temperature. Two bodies at same temperature may differ in the quantities of heat contained in them. This point clearly indicates that heat and temperature are different terms, different things. When two bodies are placed in contact, the total amount of heat is equal to the sum of heat of the individual bodies. Whereas when two bodies and different temperatures are placed in contact, the resultant temperature is a temperature in between the two temperatures. That is, you can understand this point with the help of an example. If two bodies are at different temperatures, say 40 degrees centigrade and 20 degrees centigrade, so the resultant temperature after some time of both the bodies will be between 20 degrees centigrade to 40 degrees centigrade. Absolute zero. 0 Kelvin is the temperature at which pressure and volume of a gas becomes zero. Hence, 0 Kelvin is called absolute zero. When we lit up a candle or heat wax in a bowl, the physical state of wax changes from solid to liquid. That means, on heating, wax is expanding. So the expansion of a substance on heating is called the thermal expansion of that substance. Solids have definite shape, so they expand in all directions. Hence, there is three types of expansion in solids. Number one, linear expansion. When there is an increase in length of the substance, it is called linear expansion. Increase in area of the substance is called superficial expansion, and cubical expansion is increase in volume. Since liquid and gases do not have any definite shape or size, they have only volume. So only cubical expansion is seen in liquids and gases. Now, what is anomalous expansion? The expansion of a substance on cooling in a certain range of temperature is called anomalous expansion of that substance. As in thermal expansion, we have studied that on heating a substance, it expands. But according to anomalous expansion, instead of contracting on cooling, it expands. Means when you cool a substance, it doesn't contract, it starts expanding. So this type of behavior is called anomalous expansion of that substance. According to your syllabus, we will study about anomalous expansion of water. And what does it state? It states that the expansion of water when it is cooled from 4 degrees centigrade to 0 degrees centigrade is known as anomalous expansion of water. According to the law of thermal expansion, on cooling from 4 degree to 0 degree, water should be contracted. Water should contract, but instead of contracting on cooling, it expands. That means its volume increases and its density decreases. We can study this anomalous behavior of water with the help of these graphs. On the screen, you can see a graph between temperature and volume of 1 gram of water. Water should contract, but instead of contracting on cooling, it expands. That means its volume increases and its density decreases. We can study this anomalous behavior of water with the help of these graphs. On the screen, you can see a graph between temperature and volume of 1 gram of water. We are getting a curve in the temperature volume graph. At 0 degrees centigrade, the volume of the water is more than 1 cubic centimeter. But when it starts heating, that is from 0 degrees centigrade, the temperature is rising to 4 degrees centigrade. It should expand, but rather than expanding, it's contracting. Curve is getting lower. And so you can see that when we are increasing temperature from 0 to 4 degrees centigrade, the volume of the water should increase. But instead of increasing, it's getting decrease. So this part shows the anomalous behavior of water. The volume of water is minimum at 4 degrees centigrade. The another graph is between temperature and density of water. We all know that when the volume of the water increases, its density decreases. Hence, its density between 0 to 4 degrees centigrade is increasing and its maximum at 4 degrees centigrade. After 4 degrees centigrade, density is decreasing because volume is increasing. So the density of water is maximum at 4 degrees centigrade and volume is minimum at 4 degrees centigrade. That's all for today. See you now with new topics of heat and energy in next class. Take care of yourself and study well.